John have done an
This meeting is being recorded.
they have done a number of projects around the state of Alaska, and they're actually second joint presentation. And without stealing their thunder or their time, I'm going to let them tell you more about it. Go ahead, Mike.
Well, hello, everybody. We've got a pretty interesting presentation for you here. I would like to also introduce my co-collaborator in this, John Dufendach, who is also online with us. John is actually the manufacturer of these systems, and you'll hear more about that. I'm going to go ahead and start the screen sharing now. So let's jump into the PowerPoint, and let me turn this thing on. Okay, so this is called the Rotary District 5010 Emergency Water System Project. And again, it'll be John and I are going to tag team this presentation. So this is actually a project that came about a year ago when we were having our district team training. And that was in February. But what it boils down to is we had a village, the village of Tuluksak, that actually had its washateria burned down, and it took with it the water system, and pretty much the village was without water at that point. This is a village of over 300 people, so this was a real serious emergency. And many villages in Alaska have this problem. Sometimes it's the whole system, sometimes just part of the system, for a variety of reasons. And very often it's in the winter, because we have more winter months and summer months here, of course, which complicates the recovery. So this is a picture of the Tuluksak washateria. And again, they lost pretty much everything. The emergency response came out of Bethel, the Regional Health Corporation. It took them 45 days to actually get a functional water system into the village. In the meantime, people were melting snow, melting ice. They drilled a hole in the river nearby, and they were just pumping out water, but they had to boil the water. And there was a major effort to try and ship pallets of water in, which turned out to be a disaster because the airport was closed because of heavy snow, and the only guy that could run the road grader, which was in poor repair, had COVID, and not just being quarantined, but he had COVID. He was sick. So it took nearly a week before they could even open up the airport, and it was a very long and arduous process to get everything going. So this is where a collaborative effort begins. And this is where I'm going to go ahead and let John, why don't you step in and kind of explain what you and I talked about, what we decided to do.
Yeah, well, can you hear me?
Yes.
Yeah, Mike asked me to come to Fairbanks for a meeting, just collaborate, and offered to work with Campwater Industries to see if we couldn't develop something that could be air transportable, that could be flown into these villages, that would be sufficient enough to supply a village in an emergency situation, where we could have a temporary unit that would supply drinking water drawn out of the river or lake, pond, whatever's the raw water source might be, and to supply up to 500 people. So we went home, thought about it, came back again, and suggested that perhaps we could develop something that would be helicopter transportable. And I showed Mike a sketch of what I thought maybe might be possible to do in a 6 foot by 6 foot, 6 foot high, 7 foot high rather, enclosure that's Arctic insulated, heated, with sufficient capacity, like I say, to supply somewhere in the order of 10,000 gallons a day. So Mike asked me to come up with a more detailed design, which we did. We costed it out and went ahead with the approval of Rotary 5010 to develop a prototype. And here's a sketch of the actual process unit. It has a strainer, a 2-stage filtration system, a smart meter, and a static mixer, chlorine tank and pump, And a 100, off to the right of this slide, you'll see it has a 100 micron raw water strainer, a single dual gradient 25 to 1 micron nominal filter, twin parallel carbon cyst filters, chlorine disinfection, and a contact time maintained to meet the US EPA surface water treatment rule. Next slide.
Okay, John, I'll take it from here for a little bit. So John had he had a prototype unit, a little 2 gallon per minute version of what he was proposing, and we wanted to go ahead and do a what we call a proof of concept test. And we wanted to do this under winter conditions. So this was April, and we were planning on doing this up in Fairbanks, but we had a massive snowstorm, and with access to the river was just impossible. Up near where John lives, the Tanana River actually runs open all winter long because it's fed by a huge groundwater aquifer that surfaces right there. So we were able to go down, set up right alongside the Tanana River. And this was the actual test site. You can see the 300-gallon tank in the middle there. That is actually the tank that is now in the prototype unit. The little test unit is on a table and a generator on the side to run the whole thing. And so here's a little more of a close-up. And the test unit was basically being set up by John, and I'll let you go ahead and explain a little bit about Captain Chesa.
Captain Mike Chesa is the is responsible. He's the operations officer for the Alaska State Defense Force. They have 3 different missions, one of which is to provide drinking water to in emergency situations to villages in need. So he participated and has right from the start been a participant in our development. The little unit that you see there is a very common. It's a production model that I actually have hundreds of them all around the world, called an FUV2. It does about 2 gallons a minute, but it has the same technology in it that we are developing for in a larger version to go inside of the unit that's under development for the transportable unit.
Okay, I'll pick it up from here, John. This, what we did is I set up a little field lab and did a bunch of the water quality tests, tested the raw water, and then we made 2 batches, 100-gallon batches each, and had that tested for potable water. And we actually took samples. The samples were actually collected out of this test stand, which John had built for the Alaska State Defense Force. And this is his granddaughter, Vivian Miller, who helped us out on this day. And she was demonstrating how you fill, water containers from this water filling station. And there's something like that on the unit we'll show you here in a little while. But we did run it, and we took some certified test samples, and it met potable water standards, pumping right out of the river. So this was similar water to what we would expect to see under winter conditions. John, I'll have you explain what you and Vivian are doing here.
Well, this is actually the construction of the processed frame for the unit that is now the helicopter transportable drinking water unit. You can see that it has large filters, a chlorine disinfection system at the base. Vivian is just in the process of inserting the cartridge filter. This was a little shot taken inside of our shop. You'll notice that the frame is a very robust welded aluminum frame, which is typical of the type of industrial production that we do make in our shop. And this is the construction of the top of the unit. It's 6 foot by 6 foot by about 7 foot high. And you can see the roof bows being assembled in this picture, the welding equipment, so on in the background there in our shop in Delta. So here's the completed frame. And the idea of this test was to, I wasn't sure if we were going to be able to fly this with a helicopter with the tarp on it or whether we were going to have to take it off in order to fly it. So I wanted to run an initial test without the canvas covering. So you can see here that the unit was complete with a 300-gallon tank. And this is actually the flight test that we ran without the cover on it. So here we are in a little farm in outskirts of the large metropolis of Delta Junction out over the barley fields. And here we go. This is an 80-foot or 75-foot tether, a Hughes 500 helicopter, which is one of the most popular models that you'll see it in the mines and the remote camps all over the state. I wanted this to be able to fly with a small helicopter that's commonly available. So in this test, we were able to demonstrate the efficacy of the helicopter to fly it. He went out about 5 miles out over the barley project and came back. And when he came back and said, "Go ahead, Mike."
Oh, go ahead, John.
Yeah, this flight test was donated in kind by Aurora Aviation at Delta. He reported that it flew well, that he would have about a 65-mile radius that he could fly it without refueling. Anything beyond that would require a fueling station. And he flew it at about 65 knots. So the next step was to take it into Fairbanks and get it covered with an insulated cover at custom canvas. This is actually an R6 insulation cover. And here we have a close-up shot of the fill point. You'll see on the left there, you'll see a faucet that's pump controlled. And on the right, there's a large cam lock connection so that we could actually fill tanks out at the village. And here is the, go ahead.
Yeah, I'll pick it up here for a bit. This is Devlin McKee, and Devlin owns Custom Canvas. And as John was explaining, this is a 3-ply covering on this thing. It's really amazing. It's surprisingly thick for what you would think of as a tent. But it's got the exterior weatherproof layer, then it's got an insulation layer, and then a breathable inliner fabric because it does get humid inside of there when the water system is running, so allow everything to dry out. And of course, they put reflective strips on. I had some Rotary logos made up, as you see on the left side. And then the fill point that John was just talking about is right there on the right. And this is a photo again of John, myself, and the gentleman with us here. This is Bill Justice, and he is the senior U.S. Public Health Service officer with the Tanana Chiefs Conference, and that's the Alaska Native Regional Tribal Health Consortium group in Fairbanks. It serves the whole middle of the state, pretty much the Tanana and the Yukon area. And I'm going to talk more about him here in a little while. So, John, why don't you go ahead and pick it up from here on the second flight test?
Yeah, so this test again was the second flight test so that we could find out will it or will it not fly correctly with the cover on. I was hoping that it would, so that we wouldn't have to remove the cover in order to safely fly it. And sure enough, it flew just fine. And so we're able to say that we do not have to remove the cover in order to fly it out to the site.
I'll go ahead and run a little bit of the video on this one. One of the things that we were trying to test on this was not only the cover on it, but the full loaded weight. And this was actually the second flight. So we put the pump and the hoses and all the rest of the gear in it, so it would be at the full weight of the unit when it was being carried. And by kind of scooting all that to one side, it was fairly stable in flight. It spins a little bit. The tether attaches to what's called a clevis joint, which allows it to spin. When we first flew it, it spun more than we liked, but when we loaded it with the heavier materials canted to one side, the turning rate was slow enough it could be safely landed again. I'm going to walk it all the way through, and I'm going to show you this the skill of Keith Warren, this pilot. Oh, it just kicked out of that. Let me. Bring it back to this. Okay, I'm going to just show you the landing and what these pilots can do. By the way, there were a lot of people that came out to visit this, to see this test. We had different associations and agencies and so forth that were really curious about what was going on, including a representative from the Leona Helms Foundation. Pretty interesting.
Yeah, I can jump in here and say the normal capacity of that Hughes 500 is 800 pounds. And what we have here weighs about 700 pounds. If it gets over 700, it starts to affect the fuel capacity. So we tried to keep it right at 700, and we did. So, well, he did set it on the trailer.
There he goes.
Okay, here we go. Yeah.
All right, I'm going to stop it there. All right, let's go ahead and move along. Yeah, we're short on time, so we're going to skip through this pretty quickly. So the next thing that we decided that needed to be done is a full-scale test with raw water. And so we decided to test it under summer conditions, brought it up to Fairbanks. So this is the unit on John's trailer. And our Rotary Club is building a playground in what's called the Tanana Lakes Recreation Area. So this is where we actually ran the test. And one of the changes that was done on this one is rather than use liquid chlorine, which can be hazardous to fly because it's an oxidizer, John brought this thing, which is called it's a chlorine generator, a stream chlorine generator, and it makes chlorine from salt, water, and electricity. So you don't have to haul hazardous material out. And this works so well that we now have included this as part of the package for the production units. So here's John. This is the first water we actually produced out of it. He's using the filling, 5-gallon filling tap. Yours truly again with the field test. And we did get a little bit of a fouling on the second stage filter, which we identified later on as a type of an algal fouling out of the raw water, which is strictly a summer issue. But if we wanted to use this for a summer operation as well, we'd have to have a little bit more oomph in the filtration. So John actually doubled the second stage filters. But we had Tanana Chiefs came out, the ADEC engineering staff came out, a bunch of other Rotarians. So it was a pretty neat event. Then we were contacted by the Alaska Native Tribal Health Consortium in Anchorage, and they asked us if we could bring it down and do a pilot test somewhere down there so they could see it. And we ended up selecting Seymour Lake and Wasilla. So here's the unit. Again, John towed it down from Delta. Peggy and I brought our RV down. We set up the lab under the awning. Rotarians Phil and Claire Horton donated the use of a nice paved driveway with a boat launch in this dock. Brenda Hewitt Fuller and her husband Tony live across the other side of the same lake, and they help provide logistics for this as well. So John, I'll let you take it from here for a bit.
Yeah, well, in this case, we you can see the slide or the photo on the right is actually my grandson hooking up a little shallow well jet pump, which is a bit different from the pump that we use, a submersible pump in the winter test. So we have two options for the pumping. And the hose coming out of there is actually heat traced and insulated. So it's a winter hose, but that's whether we use it winter or summer, it's the same hose. And again, on the left side, you'll see the stream system that we actually generated the sodium hypochlorite. It's actually a mixed oxidant. It's got a little bit of hydrogen peroxide in it as well. And we came up with about 5,000 parts per million. You can see the disinfectant being produced in the little container there at the lower part of the left slide. And so we use that to do the disinfection with. And here we have on the left slide here, it shows the electronic control system that's designed to meet US EPA drinking water, surface water standards. It has a timer built into it for the contact time and a sequencing operation that's a function of the float switches in the tanks, and a lot of automatic stuff I'd be glad to discuss in any details that anybody wants. So in the center slide, you can see that we have this insulated sock that comes off the side of the unit, and both the hose and the electrical cables are inserted there, but that can be zipped up for the winter so that it preserves the heat inside. So we actually ran a full load power test with the heater running as though it were to be used in the winter. And in that particular test, we had a 7.5 kW portable generator that ran the whole thing.
We did this over a 2-day period, and on September 7th, we did the setup and the performance test and the electrical load test. So on the 8th, we actually did the pilot test. We invited a bunch of people out. So we had 15 guests, again, the ADC engineering staff, Alaska State Defense Force, Alaska Native Tribal Health Consortium, of course, they were the ones that requested this one, and another group called the Alaska State Emergency Operations Center, which is the response group that actually responds to a disaster. And then a very important group, the Denali Commission. And the tall gentleman in the just to the left of center is Tom Wolf. He's talking to Peggy there. And he was at the time was the head of water projects for the Denali Commission. We'll talk more about them in a moment. So it was a really amazing test, but John was doing tours of the water plant, and I was showing the lab work and doing a little bit of a description of. I was in this slide on the left. I was showing some of the flight testing that we had done with the helicopter. But I wanted to just show you a quick summary of the 3 tests that we did: the April proof of concept, and then the 2 pilot tests in August and September in Fairbanks and Anchorage, or Wasilla. The top 2 rows here are raw water samples. And this is the bacteria results. So there's total coliform, and the actual drinking water standard is the type of coliform called Escherichia coli. And the standard is 0. You can't have any of these in drinking water. And the raw water was contaminated on both or all 3 sites. But the treated water, as you can see, met the drinking water standards. These tests were actually run at Peggy's and my son's laboratory in Fairbanks, which is a certified lab. And all of that, all the pilot testing, all the flight testing, all of that has been donated in kind to the project. So what remains to be done is John and I are working on the fouling potential to see if we can make this thing work better under the summer conditions. But we've got some more tests that are planned. This was a little filter that he had put together, which is a pre-filter, actually a washable pre-filter, to see if we could take out the algae. This partially work, but we're gonna upgrade that. John has some other filters he wants to add on.
If I can.
Sure.
If I can jump in there, I'm working with an engineer who is a design engineer with the Amiad Filtration Company, and they have developed an algae filter that uses discs right in that little test unit there. You can see the algae filter. Yeah, thank you for pointing that out. That was a 50 micron filter, and it didn't do as well as we had hoped. But the company has also developed a 20 micron filter that we'll be testing this summer. And but we ran out of time for that particular.
We ran out of open water.
Yeah, the water was frozen by then.
Okay, so the next thing that happened is back to you remember Bill Justice, the picture of John and Bill and I. He and one of the other regional health corporation engineers we've been working with up out of the Maniloc Association up in Kotzebue, asked if could we build this to fit inside of a Caravan, a Cessna 208, which has a 4x4-foot cargo door. And then it's kind of a funny story. John says, "Oh no, there's no way we can do this." So this was John's design that actually does this. The unit actually has been now constructed and tested. So one thing I learned about John Dufendach is don't show him something that he thinks he can't do, and then give him about 6 hours to think about it, because he'll actually build the thing. But it's built in a couple of different, there's 2 standing modules, each have 2 4x4 components. And otherwise the treatment system is very similar to the helicopter design. So just a few notes on deployment. I'll go through this fairly quickly. So what we're doing is we built, past tense, 3 helicopter transportable units, 1 of the fixed wing transportable units. And then our Rotary district is going to gift these to the Tanana Chiefs Conference in Fairbanks, and then the regional health corporations in Bethel, Kotzebue, and Nome. And the reason why we're giving them to those organizations, they will own them, is because they each have a USPHS engineer that works with the water and wastewater systems in the region. They have a staff of remote maintenance workers who are certified operators and mechanics who go out to the villages routinely to work on the systems. They will be the people that actually help to deploy this. Then John and I are going to do a training program for them at Fairbanks. We're going to have an MOU that explains that they are liable for, own the system, they have to maintain it, and this is really only an emergency response system for winter conditions. John, why don't you fill in the details here for a bit?
Okay, well, on the right, you can see the frame of this fixed wing transportable unit, and the top bolt to the bottom, so that both of those components will fit through the cargo door of a Caravan aircraft. So they come apart. The tank ships separately, and so as you can see. Okay, well, yeah, now this is in the custom canvas facility again in Fairbanks, where we had them build the canvas strip, but it all comes apart. In fact, we're in the process right now of disassembling one of these units, and we'll be doing the training to show the people how to assemble it. On the right, that right picture is actually, yeah, thanks. That's actually of the helicopter transportable unit, but we thought, it'd be kind of nice if we could make a provision where once that unit gets set out there on the ice, there's a way for a couple of snow machines to skid it around. And so we put this HDPE all the way across, made a skid across the bottom, and then a good towing hook on each corner. So that the village would have a way to move it off of the ice. Let's just say if breakup is coming, we want to be able to move that thing. And here's my crew on the right, including our little cheerleader. We have here my project superintendent, my welder, my plumber, my electricians, and the old guy with the hat there that just stands and watches while they do all the work. In the center picture there is the submersible pump frame, and which sets on the ice, and let's just set a submersible pump in there. We drill a hole in the ice, set the pump through there, and then on the left is the completed Caravan transportable unit. These pictures are all taken in my shop in Delta. Go ahead, Mike.
I'll be back up. Just a quick note on the budget. The whole project right now is clocking in at about $360,000. I think it's going to finally end up being closer to $400,000. Of that, we're expecting about $150,000 is going to be donated in kind by John's company, my company, our son's company, and Aurora Aviation. The first prototype unit was funded in part by a $25,000 excess reserves grant from our district. So that was the seed money that our district put in. We are right now asking the clubs to raise the rest of the $15,000 so we can complete the payment for that one for the first unit. And then 2 additional helicopter transportable units, the ones that have already been built, was funded by a Denali Commission grant. So the Denali Commission has come in and they are now waiting for what they call the phase 2 grant, which will pay for the caravan transportable unit. And then finally, the delivery of the units, we're hopeful that we may be able to get back to the Alaska State Defense Force and Air National Guard has got some new Chinook helicopters, and they're hoping to be able to transport these units out as a test exercise. So that's coming. And then this week, Monday and Tuesday, we tested the units in the full-blown winter test. This is John and I with both models, the fixed wing transportable and helicopter transportable. There's the pump unit. The pump is in the water and it survived overnight, did a great job. And this is John. And then the lady here, Kristen Reardon, she took Tom Wolf's place and she came up for this and helped out to actually run the performance test. And of course, we did this on the gravel pit at Whitestone Farms, and they brought the high school science class out. So this was doing a lecture for the kids here. They really enjoyed it. And then Noah Sagonis, he's one of the Tanana Chiefs Conference engineers, and he is actually the head of the remote maintenance workers for the group in Fairbanks. And so we set them up, we operated them, left them overnight. They stayed thawed. The pump was thawed. Both operated beautifully with very little fouling of the filters. And we had very clear water conditions. But anyway, that was a very successful winter test. We're waiting now for the final test results on that. And that is our presentation. So thank you, Rotary Club of Ketchikan for sitting.
So, Mike, how do people get in touch with you if they have questions? We're running really short on time. Can you hear me, Mike?
No, I can hear you, but I can't hear anybody else.
Okay, so how do people get in touch with you if they have questions?
No, can't hear you.
Right. I will email you. Thank you, Mike.
You're welcome, Michelle.